So now we're going to graph some linear graphs. We want you to complete the table and show any work if you need to, and then we're going to plot the lines. So because all of these are linear, all of the graphs will be straight line graphs. On this particular problem, notice that the y is all by itself here. So whenever the y is all by itself, it's easiest to pick values for x. These are my favorite 5. I usually go straight to -2 to +2. Unless they don't work or I need more points, then I pick more points if I need to. But these are always what I start with because they're my favorite. So in the first part, I'm going to plug in 2 to x. Why do I plug in 2? Because I have to start with something. So I'm going to start with -2 to +2. So I'm going to start with -2. So I have -3 times -2 plus 6, which is equal to 6 plus 6, or 12. Then I'm going to go ahead and plug in the next one. Every time I see an x, I'm going to plug in the value that's located in the table. Keep going down. Y is equal to -3 times x, but in this case my x is 0. Next one, y equals -3 times x plus 6, but instead of x, I put a big old fat parentheses and stick in my value of 1. -3 plus 6, that's 3. And y is equal to -3 times 2 plus 6, which is -6 plus 6, which is 0. Okay, so now I have 1, 2, 3, 4, 5 ordered pairs. I'm going to go ahead and plot all the ordered pairs that I can. Now I just started with -2 to +2 because I needed to start somewhere. But when I go to plot -2, 12, -2, 1, 2, 3, 4, 5, 6, 7, my graph only goes to 7. So is this a bad point? Well, no, it's not a bad point. It's just off my graph. So I'm going to exclude it from graphing it because I just can't fit it. Same thing for -1, 9. My graph only goes to 7. So although they're not bad points, they're still solutions. I just can't fit it on my graph, so I'm going to start with the ones that I can fit. So 0, 6, I go left and right 0 and up 1, 2, 3, 4, 5, 6 right here. 1, 3 and 2, 0, and that is enough to create a pretty good straight line here. So I have now graphed that linear equation. Let's try another one. Okay, so I'm going to start the next one with my same 5 values. Notice this one is not solved for x, so this might take me just a little bit longer than some of the other ones. So I have 5 times x, but x is really, in this first case, -2. Minus 2y equals 0. So that gets me -10 minus 2y equals 0. I'll add 10 to both sides. So notice that this is a whole lot more work than the last problem. So I'm getting y is equal to -5. To do the next problem, I'm going to do this in red just so you can see the difference of which one is which. So I have 5 times x, but this case x is -1. So that's -5 minus 2y equals 0. Add 5 to both sides. -2y equals 5. Divide both sides by -2. So I'm getting -5/2, which is like -2.5. But graphing fractions is no fun. Now this is not a bad value, but I might eventually choose maybe not to use it, or maybe use it as a checker point, because again I picked the x values for -2 to +2 just because I had to start somewhere, but that doesn't mean I have to plot all of them. I really only need 2 points to draw a straight line. 3 would be best. Let's try the next one in green. 5 times 0 minus 2y equals 0. Well, 5 times 0, that's nice. That's just 0. Divide both sides by -2. I'm getting y is equal to 0. That's a good point. Nice, good point to graph. Let's see. Let's try gray. I'm going to do 1 in gray. So I have 5 times 1 minus 2y equals 0. So that's 5 minus 2y equals 0, minus 5 from both sides. And I have y equals negative divided by negative is a positive 5/2. And then my last one, I'll try an orange over here. 5 times 2 minus 2y equals 0. So that's 10 minus 2y. Subtract 10 from both sides. So negative 2 equals negative 10. Divide both sides by 2, negative 2. And that leaves me with y equals positive 5. So then I'm going to go back and plot all these points. Negative 2, negative 1, 2, 3, 4, 5 is down here. My red point is negative 1, 5/2. 5/2 is 2.5, so that's like 2 and some. Maybe a little hard to graph. If you choose not to graph that one, you probably are going to be okay. 0, 0. My gray point is 1, 5/2, positive 5/2, which is positive 2.5. And then my last one in orange, 2, 5. 3, 4, 5 right here. And notice all of them are in a straight line, which means I probably didn't make any mistakes. And I draw a straight line through it, put arrows at the end, and I've drawn a great linear equation. That one was a whole lot more work than the other one, although you probably really only need 3 points. 2 is a minimum, 3 is pretty good, 5 is perfect. This is looking like a great graph to me. So not all graphs will be linear. So next what we're going to explore is what graphs look like when one of the variables is squared and the other one is not squared. These equations are called quadratic equations. So if the x is squared and the y is not, like y is equal to x squared, notice the x is squared but the y is not, then the graph is going to look like that. We call this a parabola or quadratic equation. When the x is squared, it's going to be pointing up, or technically it could be pointing down if there's a negative in front of the x squared. But if the y is squared and the x is not squared, like this, do you see how that y is squared but the x is not? Then the graphs will look like the same U shape but kind of sleeping or on its side. Again, if you have some negatives, it might end up being over here. But in this particular problem, it is the one on the right. So I'm going to go ahead and erase these two because although that's possible, it's not actually the one that was given. So let's go ahead and plot some of these. So the quadratic equations, I'm going to again start with my favorite 5. Notice this one is solved for y. Yay, that's really good news. Because when I go ahead and plug in my x values, y is already solved, so all I have to do is evaluate the right-hand side. So this is 4 plus 2, which is just 6. Much easier than trying to solve if it's not already solved for one variable. So my next one, y equals x squared plus 2, where x is negative 1. Negative 1 squared is 1. 1 plus 2 is 3. Let's keep going. Y is equal to 0 squared plus 2. That's 0 plus 2 equals 2. Y is equal to 1 squared plus 2, which is 1 plus 2, or 3. And then y is equal to x squared. X is now 2 plus 2, which is 4 plus 2. Alright, so now we have 5 really good points. Let's go ahead and plot them. Negative 2, 1, 2, 3, 4, 5, 6, right up there. Negative 1, 3, 0, 2, 1, 3, and 2, 6. Look at that. That's a nice U shape. Okay, so do you think I really needed all 5 points this time? The answer is yes. in linears, you really only need 2 and you can make a pretty good straight line. A third point just to make sure you've not any mistakes. But in quadratics, you really need a lot of good values in order to get a good picture. So I would say at least 5, if not more. Let's try the next one. Notice again, this is solved for y. So because it's solved for y, plugging in values for x's is going to be really simple. So let's go ahead and pick a whole bunch of x's. We're going to start with -2 to +2 because those are my favorites. So we have y equals 3 minus x squared. Now this one's a little tricky because there's a minus in front of the x squared, which confuses people sometimes when they're doing their PEMDAS. Notice I'm putting the -2 inside the parentheses. The minus from the formula still stays outside of the parentheses. -2 squared is 4. So this part right here is 4, but notice the minus still stays, and that gets me -1. 3 minus, because there's a minus in the formula, parentheses -1 squared. Now, -1 times itself -1 because exponents come first in PEMDAS before subtraction. So I do -1 squared, which is +1. Now, minus still stays because we haven't done that minus out here. 3 minus 1 is 2. 3 minus 0 squared is 3. Y is equal to 3 minus 1 squared. And when they're positive, it's a little bit easier. Students don't make as many mistakes on positive ones. So I have 3 minus 2 squared. That's 3 minus 4, which is -1. So let's plot these. -2, comma -1. -1, comma +2. 0, comma +3. 1, comma +2. 2, comma -1. And now I've got that nice pretty graph. Notice that in this case it is pointing down instead of pointing up. Beautiful. Let's try another one. On this particular problem, notice the x is what's solved. So I'm going to be a little bit sneaky here, and instead of plugging in x's, which are going to take a long time to try to solve, and we haven't actually taught you how to solve those kinds of problems yet, what I would suggest is plugging in values for y. And the reason I want you to plug in values for y is because x is already solved. And the x is the thing I'm trying to look for. Once I pick an y, then I'm trying to look for x. And the thing that we're looking for should be simple. We want things to be simple for us. So I'm going to do -2 squared plus 3, plugging in the -2 in for the y this time. So that gets me 4 plus 3, which is 7. And notice how simple that was because the x was solved this time. So x is equal to y squared, which in this case, the next case is -1 squared, plus 3, which gets me a solution of 4. 0 squared plus 3 was 0 in for y. The next one I'm going to plug 1 in for y. And the last one I'm going to plug in 2 for y. Once I've got that graph, I'm going to plot it. 1, 2, 3, 4, 5, 6, 7, comma -2. 4, comma -1. 3, comma 0. 4, comma +1. And 7, comma +2. Now when I graph that, I have a U shape but lying down.